In the vast and desolate heart of Siberia, there exists a silence so profound that it feels heavy against the eardrums. This is the Tunguska Basin, a region defined by its isolation and its savage beauty. For thousands of years, the only masters of this domain were the bears, the wolves, and the nomadic Evenki people who tracked reindeer across the endless taiga. It is a landscape of swampy bogs and thick forests of pine and larch. Rivers wind through the mossy earth like veins carrying the lifeblood of the frozen north. Here, the winters are long and brutal, shrouding the world in darkness and ice. But in the short burst of summer, the land comes alive with a frenzy of insects and the bloom of wildflowers. It was here, in this remote theater of nature, that the sky decided to tear itself apart. The date was June the 30th in the year 1908. The world outside of Siberia was marching toward the brink of its own mechanical age. In Europe, great powers were playing diplomatic chess that would eventually lead to the trenches of the First World War. In America, the Ford Model T was just months away from rolling off the assembly lines. Humanity felt invincible, believing that it had tamed the elements and conquered the globe. But in the early morning hours of that Tuesday, nature would offer a terrifying reminder of our insignificance. The sun had risen over the Podkamennaya Tunguska River, bringing with it the promise of a warm summer day. For the Evenki herdsmen sleeping in their tents or tending to their reindeer, the morning began as any other. The air was still, and the birds were singing in the canopy of the ancient trees. There was no warning sirens. There was no forecast predicting the cataclysm. At roughly 7:17 in the morning, the fabric of the atmosphere was punctured. High above the Indian Ocean, an object from the depths of space had entered the Earth's trajectory. It was a traveler from the dark void, likely a stony asteroid, or perhaps a fragment of a comet. It was hurtling toward the planet at a speed of tens of thousands of miles per hour. As it slammed into the upper atmosphere, the friction turned the rock into a blazing torch. It tore across the sky, moving from southeast to northwest, leaving a trail of smoke and fire that spanned the horizon. Witnesses hundreds of miles away stopped in their tracks, eyes fixed upward in disbelief. To them, it looked as if the sun had fallen from its zenith and was rushing to meet the Earth. The light was brighter than the daylight, blinding and iridescent, with shades of blue and white. Those who saw it described a cylindrical form or a ball of fire, followed by a tail of multicolored smoke. The object screamed as it descended, compressing the air before it into a wall of solid pressure. It did not strike the ground. This is the most crucial and baffling detail of the entire event. At an altitude of roughly 5 to 10 kilometers above the surface, the stress became too great. The intruder detonated. The energy release was apocalyptic. Estimates suggest the explosion unleashed the energy equivalent of 10 to 15 megatons of TNT. This was not a simple bomb. This was a force 1,000 times more powerful than the atomic weapon that would later decimate Hiroshima. But in 1908, the concept of splitting the atom was still science fiction. The explosion created a second sun in the sky, a flash of thermal radiation, so intense it could be felt on the skin 40 miles away. A farmer named Semyon Semenov was sitting on the porch of his house in the trading post of Vanavara. Vanavara was 40 miles south of the epicenter, a distance that should have been safe. Semenov later recounted that he saw the sky split in two, and fire appeared high and wide over the forest. The heat was so intense that he felt as if his shirt was on fire. He instinctively tore at his clothes, trying to escape the invisible flames. Then came the shockwave. The explosion displaced millions of tons of air, sending a blast wave radiating outward at the speed of sound. It slammed into Semenov, throwing him off his porch and knocking him unconscious. Windows in the village were shattered. Doors were blown off their hinges. The ground shook as if a great beast was thrashing beneath the soil. Further north, closer to the blast point, the devastation was total. The shockwave hit the forest with the force of a divine hammer. 80 million trees were instantly flattened. They fell in a radial pattern pointing away from the center, like matchsticks dropped by a giant hand. The heat of the explosion instantly scorched the bark and ignited the moss. A firestorm ensued, consuming what little life remained in the immediate vicinity. Hundreds of reindeer, the livelihood of the local Evenki, were incinerated in a flash. Their charred remains were all that was left of the herds that had grazed there moments before. Tents were blown away, along with the people inside them. Those who survived the initial blast were left deafened and traumatized, wandering a landscape that had been transformed into hell. The sound of the explosion was heard over 800 miles away. It was a thunderclap that did not end, a roaring rumble that echoed across the Siberian plains. Trains on the Trans-Siberian Railway halted as drivers feared their boilers had exploded or that the tracks had been sabotaged. Seismographs in locations as distant as Irkutsk and Tbilisi, and even Jena in Germany, registered the tremors. The earth rang like a bell. The atmosphere was thrown into such turmoil that the pressure waves circled the globe twice. In London, barometers twitched, detecting the ghostly pulse of the Siberian airburst. But the strangest phenomenon was yet to come. In the days following the event, the night sky over Europe and Asia refused to go dark. The explosion had injected massive amounts of dust and water vapor into the upper atmosphere. These particles caught the sunlight from the other side of the world and scattered it, creating noctilucent clouds. People in London and Paris and Berlin walked out into the streets at midnight to find the sky glowing with an eerie phosphorescent light. It was bright enough to read a newspaper in the middle of the night without a street lamp. Photographs could be taken at 2 in the morning. The white nights became a source of fascination and dread. Newspapers speculated about the end of the world, or strange magnetic storms, or the shifting of the poles. But because the explosion had occurred in one of the most inaccessible places on the planet, no one knew the cause. Communication with the deep Siberian interior was slow and unreliable. The Tsarist government in Russia was beset by internal strife, and revolution was brewing in the streets of St. Petersburg and Moscow. The remote problems of the Tunguska region were of little concern to the ruling elite. Rumors began to circulate among the tribes and the traders. The Evenki spoke of Ogdi, the god of thunder, who had descended to punish the people. They believed the land was now cursed. They refused to go near the fallen forest, fearing the angry spirits that lingered in the smoke. And so the site of the greatest impact event in recorded history lay undisturbed for nearly 2 decades. The trees rotted where they fell. The seasons turned, covering the scars with new growth and winter snow. World War I erupted, tearing Europe apart and consuming millions of lives. The Russian Revolution toppled the Romanov dynasty, and the Soviet Union rose from the ashes. It was not until 1921 that the scientific community finally turned its gaze toward the mystery in the East. A mineralogist named Leonid Kulik was the man who would dedicate his life to solving the riddle of Tunguska. Kulik was a man of intense focus and boundless energy, possessing the beard of a patriarch and the eyes of a visionary. He had been tasked by the Soviet Academy of Sciences to survey the country for meteorites. The new Soviet state was hungry for resources, and iron from space was considered a valuable commodity. Kulik stumbled upon the old reports of the 1908 event. He read the newspaper clippings about the bright nights and the distant thunder. He interviewed witnesses who had moved away from the region. He became convinced that a massive meteorite made of iron had struck the taiga. If he could find it, the iron would be a boon for Soviet industry, and the discovery would bring glory to Soviet science. But getting to the site was a task of Herculean difficulty. The region was still as wild and roadless as it had been in 1908. Kulik's first expedition in 1921 failed to reach the epicenter due to harsh conditions and lack of supplies. He returned to Moscow frustrated but undeterred. He spent the next 6 years lobbying for funding and gathering equipment. Finally, in 1927, he launched a new expedition. Kulik and his small team traveled by train to the edge of civilization. Then they switched to horses, and finally they had to rely on reindeer and their own feet. They battled swarms of mosquitoes that were so thick they clouded the air like smoke. They waded through swamps that threatened to swallow them whole. They endured the biting cold of the Siberian nights and the scorching sun of the days. They relied on local Evenki guides, but the guides became reluctant the closer they got. The guides warned Kulik that they were entering the Forbidden Zone, the place where Ogdi had smashed the earth. They told him that anyone who entered would never return or would be cursed with sickness. Kulik pressed on, driven by the obsession of the explorer. After weeks of grueling travel, they reached a ridge overlooking the valley of the Podkamenaya Tunguska. What Kulik saw took his breath away. He expected to find a crater, a hole in the ground where the meteorite had buried itself. Instead, he saw a landscape of total devastation that defied logic. As far as the eye could see, the forest lay dead. Millions of trees were stripped of their branches and bark looking like bleached skeletons against the green undergrowth. They were all felled in a strict pattern, radiating outward from a central point. Kulik descended into the valley, expecting to find the impact crater in the center of the fallen trees. He pushed through the tangled mess of timber, climbing over the trunks of giants that had stood for centuries. When he finally reached the calculated epicenter, he stopped in confusion. There was no crater. There was no giant piece of iron jutting from the earth. There was only a swampy bog and a stand of trees that were still standing upright. These standing trees were a paradox. While everything around them for miles had been flattened, these few trees at the very center remained vertical. However, they had been stripped completely of their branches and their bark. They looked like telegraph poles planted in the mud. Kulik realized that the explosion had happened directly above them. The shockwave had pressed straight down, compressing the branches against the trunk, or shearing them off entirely but leaving the trunk standing. It was the first confirmation that the Tunguska object had exploded in the air, not on the ground. But where was the meteorite? Kulik refused to abandon his theory of an iron impactor. He spent years searching the swampy depressions, believing them to be small craters. He drained the bogs with laborious hand pumps, hoping to find fragments of the space rock at the bottom. He found nothing but old stumps and peat. The winters came and went, and Kulik returned again and again. He built a cabin in the devastation zone, turning it into a base of operations. He weathered temperatures of 40 degrees below zero. He documented the butterfly pattern of the fallen trees, mapping the direction of the blast with meticulous precision. His work proved that the explosion was indeed a single point source, and that the energy released was astronomical. But the absence of a main body of the meteorite haunted him. The scientific world began to debate the nature of the event. If it was a meteorite, where was the rock? If it was a comet, could it have been made of ice that simply evaporated upon impact? A comet is essentially a dirty snowball, a mixture of ice, dust, and gas. If a comet struck the atmosphere, the heat would flash vaporize the ice instantly. There would be no solid crater, only a massive airburst and a residual dusting of particles. This theory gained traction, as it explained the lack of a stony remnant. It also explained the bright nights in Europe, as the tail of the comet would have dispersed dust into the upper atmosphere. But the debate was far from settled. The mid-20th century brought the atomic age, and with it a new lens through which to view Tunguska. When the atomic bombs were dropped on Hiroshima and Nagasaki, scientists noticed striking similarities. The wooden structures in Japan directly beneath the blast remained standing, while those further away were toppled. The heat patterns, the shockwave dynamics, and the mushroom cloud all mirrored the descriptions of 1908. This led to a new wave of speculation. Could Tunguska have been a nuclear explosion? Science fiction writers and fringe theorists seized upon this idea. Some suggested that an alien spacecraft powered by a nuclear engine had crashed in the Siberian wilderness. The crashed saucer theory became a staple of pop culture and conspiracy folklore. Stories emerged of strange metal debris found in the taiga or of radiation sickness among the locals. However, scientific expeditions in the post-war era found no evidence of elevated radiation or extraterrestrial alloys. The traces of isotopes found in the soil were consistent with the global fallout from nuclear testing in the Cold War, not a local event from 1908. Yet the mystery persisted, enticing generation after generation of researchers. In the 1970s and 80s, computer simulations began to model the impact. They confirmed that a stony asteroid roughly 50 to 60 meters in diameter, entering the atmosphere at a shallow angle, could produce the observed effects. The immense pressure of the air ahead of the rock would cause it to flatten and fragment, effectively turning it into a cloud of debris and energy in a fraction of a second. This rapid disassembly would look exactly like a nuclear explosion without the radiation. The telegraph pole effect was perfectly predicted by these models. But even with computers, the search for physical evidence continued. Scientists looked for microscopic spherules, tiny glass beads formed when rock is melted and sprayed into the air. They found them in the resin of the trees and in the layers of peat dating back to 1908. These spherules contained high concentrations of iridium and nickel elements, rare on Earth but common in asteroids. This was the smoking gun, or at least the microscopic dust of the gun. It proved the object was cosmic in origin. But the Tunguska event is not just a story of rocks and physics. It is a psychological drama about our vulnerability. For decades, humanity had lived with the illusion that the sky was a static backdrop. Tunguska shattered that illusion. It proved that the Earth travels through a shooting gallery. We are moving targets in a cosmos filled with debris left over from the formation of the solar system. If the Tunguska object had arrived just 4 hours later, the rotation of the Earth would have placed the impact zone not in the desolate taiga, but over the city of St. Petersburg. The capital of the Russian Empire would have been erased from the map. Hundreds of thousands of people would have been vaporized in an instant. History would have taken a radically different course. If it had struck over London or New York, the devastation would have been unimaginable. The Tunguska event serves as a cosmic warning shot across the bow of civilization. It happened in the one place where it could happen without ending a nation. It was a stroke of luck so profound it is terrifying to contemplate. In recent years, the interest in Tunguska has been reignited by the Chelyabinsk meteor of 2013. On a cold February morning, a smaller asteroid about 20 meters wide exploded over the Russian city of Chelyabinsk. Dashcam videos captured the blinding flash and the streak of smoke. The shockwave blew out thousands of windows and injured over 1,000 people with flying glass. Chelyabinsk was a miniature Tunguska. It provided modern scientists with a wealth of data to calibrate their models of the 1908 event. It showed us exactly how the airburst mechanism works. It validated the accounts of the Evenki and the observations of Kulik. Yet mysteries still remain in the Siberian swamp. Some researchers have turned their attention to Lake Cheko, a small deep lake located about 5 miles from the epicenter. The lake does not appear on maps prior to 1929. Its shape is elliptical, unlike the other flat-bottomed oxbow lakes in the region. Sonar readings have suggested a dense anomaly buried deep beneath the lakebed. Could this be a fragment of the asteroid that survived the explosion? Could Lake Cheko be the crater that Kulik spent his life searching for? The debate is fierce and the evidence is inconclusive. Drilling into the lakebed is difficult and expensive, and the results have been ambiguous. Some argue the lake is ancient and the anomaly is just compacted sediment. Others cling to the hope that a piece of the celestial visitor lies sleeping beneath the dark water waiting to be found. Today, the Tunguska site is a protected nature reserve. The forest is slowly recovering. The trees that were flattened are now moss-covered mounds decaying back into the earth. New pines have grown tall, concealing the scars of the past. But if you walk through the zone, you can still see the signs. You can see the strange, twisted growth of the trees that survived the blast. You can feel the stillness that seems to hang over the valley. It is a place of pilgrimage for scientists and dreamers alike. It is a monument to the power of nature and the fragility of our existence. We build our cities and write our histories, assuming that tomorrow will be like today. We worry about economies and borders and politics. But high above our heads, in the silent vacuum of space rocks the size of mountains, are tumbling through the dark. Most of them will miss us. Some of them will burn up as harmless shooting stars. But every once in a long while, the dice roll against us. Tunguska was a reminder that we are not the masters of this planet. We are tenants living at the mercy of a universe that is violent and unpredictable. The story of Tunguska is not just about what happened on that June morning in 1908. It is about what could happen tomorrow. It is a story that is still being written by the astronomers who scan the skies looking for the next threat. It is a story of the brave men like Leonid Kulik, who ventured into the unknown to seek the truth. And it is a story of the Evenki, who witnessed the wrath of Ogdi and learned to live in the shadow of the fire. As the sun sets over the taiga, casting long shadows across the regenerating forest, the mystery of Tunguska endures. It whispers in the wind that rustles the birch leaves. It sleeps in the mud of the swamps. It glows in the memory of the white nights. The day the sky exploded was a moment when the universe touched the earth. It left a fingerprint that time cannot easily erase. We study it, we model it, and we theorize about it because we need to understand. We need to know if we can stop it from happening again, because next time we might not be so lucky. Next time the target might not be a lonely forest in Siberia. Next time the sky might explode over a city teeming with life. And so we watch the stars with a new appreciation for the darkness. We listen to the silence of space, hoping it remains silent. But in the back of our minds, we remember the roar that shook the world. We remember the trees that lay like fallen soldiers. We remember the heat that felt like a shirt on fire. We remember Tunguska. The event stands as a singular point in history, a benchmark for catastrophe. It challenges our understanding of planetary defense. Before Tunguska, we did not truly understand the kinetic potential of the cosmos. Now we know that the energy of motion can be converted into the energy of destruction in a heartbeat. The kinetic energy of the Tunguska impactor was derived simply from its speed and mass. It carried no warhead. It needed no fuse. It was a bullet fired by gravity. This simplicity is what makes it so terrifying. There is no technology to disarm a rock. There is only the physics of deflection or destruction. The legacy of Kulik's work is the foundation of modern asteroid research. His meticulous maps and photos are the baseline against which all simulation data is compared. Without his obsession, we might have lost the physical record of the event entirely. The forest would have overgrown the fallen trees, and the witnesses would have died taking their stories to the grave. Tunguska would have become a myth, a legend of the indigenous people dismissed by modern science. Instead, it became a case study. It became the Rosetta Stone for understanding impact events. It taught us about the behavior of shockwaves in the atmosphere. It taught us about the thermal pulse that precedes the blast. It taught us about the resilience of nature. The biosphere of the Tunguska region was decimated, but it was not destroyed. Life returned. The insects came back, the birds returned to nest, and the seedlings took root in the ash. It is a testament to the endurance of life on Earth. But it is also a cautionary tale. The dinosaurs did not have a space program. They did not have telescopes to watch the sky. They could not prepare. We have the tools and the knowledge. Tunguska gave us the motivation. It showed us the stakes. Every telescope that tracks a near-Earth object is paying homage to the event of 1908. Every simulation of an asteroid deflection mission is a response to the lesson of the Tiger. The International Asteroid Day is observed on June 30th, the anniversary of the Tunguska impact. It is a global day of awareness, a day to look up and remember. It serves to educate the public about the risks and the opportunities of space, because space is not just a void. It is a dynamic environment filled with resources and hazards. The iron that Kulik sought may one day be mined from asteroids to build our future. The very rocks that threaten us could become the stepping stones to the stars. But first, we must survive them. We must bridge the gap between the primitive fear of the thunder god and the scientific mastery of orbital mechanics. We must become the guardians of our own planet. The narrative of Tunguska spans from the shamanic chants of the Evenki to the supercomputer clusters of NASA. It connects the past to the future. It connects the superstitious dread of the unknown to the calculated risk assessment of the modern era. And at the center of it all lies the silent forest, the place where the sky fell, the place where the earth burned, the place where the mystery still breathes. Imagine standing there today. The air is crisp and clean, smelling of pine resin and damp earth. The ground is soft underfoot, spongy with layers of moss. You are miles from the nearest road, hours from the nearest cell phone tower. You are alone in the wilderness. But if you close your eyes, you can almost hear the echo. You can almost feel the ground tremble. You can imagine the blinding light that turned night into day. You can sense the ghost of the explosion that changed the world. It is a feeling of awe mixed with a primal fear. It is the realization that we are small and the universe is vast. It is the legacy of Tunguska, and it is a story that will never truly end, as long as we look up at the stars and wonder what is coming next. The universe is a crowded place. Traffic is heavy in the solar system. Orbits cross and paths intersect. It is a cosmic dance that has been going on for billions of years. We have only just joined the dance floor. We are still learning the steps. Tunguska was a stumble, a misstep in the waltz of the spheres. But we are learning, we are watching, and we are waiting. Because the sky is beautiful, but it is also dangerous. And on that day in 1908, it showed us its teeth. The scar on the Siberian landscape is healing, but the scar on the human psyche remains. It reminds us to be humble. It reminds us to be vigilant. It reminds us that our time here is a gift, not a guarantee. So let us remember the day the sky exploded. Let us remember the silence that followed. And let us ensure that such a silence never falls upon our cities. The story of Tunguska is our story. It is the story of survival in a violent universe. And it is a story that continues with every beat of our hearts and every rotation of our world. End of transmission.